If we want to preserve food products at low temperature, of course, we have to mention refrigeration and freezing. These are methods that use low temperatures for preserving foods, but the grade of the temperature that they use are different. For example, the refrigeration usually use temperature between 0 and 8 degrees. Although the temperature between 1 to 4 degrees are considered safe refrigeration temperature for preserving food. In this case, the shelf life of food products will be extended by several days or even weeks for some specific products. When we talk about freezing, well, freezing use very low temperature. They are usually between minus 18 degrees till minus 35 degrees. Well, the storage life of food products by using freezing and sub-freezing temperature will be extended by several months. But what I want to mention in this case is that by freezing, many changes may be caused to the food product. The food in this case will change the color, will change the texture, but there are some products like meat or fish that need this very low temperature. And there are some particular foods that needs even minus 35 degrees of temperature for preserving, and of course saving or having their quality parameters on the right levels for more time, for during the storage time. One of the most important parameters during the freezing process is the freezing time, which is defined as the time required to lower the product temperature from its initial temperature to a certain desired temperature. Well, since the temperature distribution within the product varies during the freezing process, generally the thermal center is taken as a reference. We know that freezing times depends on several factors, and the most important are dimension and shape of the food product, particularly their thickness, initial and final temperature of food product, temperature of refrigerating medium, surface heat transfer coefficient of the product, and change in the enthalpy, thermal conductivity of the product. Well, calculating the freezing time in food system is very difficult compared to pure systems, and as the freezing temperature constantly changes during the process. The time required for freezing food product, which is also estimated as freezing time, is the time elapsed between initial freezing to a full freezing of the product. Early attempts to freeze food products resulted in pure quality product due to a large crystal that are formed. The degree of freezing in the food product has a major effect on the size of the ice crystals and the quality in the structure and nutritional and sensory properties of many food products. Well, during slow freezing, ice crystals can grow to a large size, and these are problematic and are not desirable because they can destroy the cell walls, and causing in this way the degradation of the structure and loss of natural fluid during thawing. But if we have a rapid freezing, a large number of ice crystals begins to form immediately, and they are in smaller size. These are more comfortable for the food product because they do not destroy the cell's wall, and the product isn't deteriorate in this case. This is the reason that it is advisable to use the rapid freezing method. Well, refrigeration and freezing are used mostly to extend the shelf life of food products. Well, this extending is made by using these low temperatures that might slow down many chemical and biological processes in food or reactions. Well, these processes or reactions are related with the deterioration and loss of the quality and nutrients in food products. Let's mention some examples of food products, how help or how available are refrigeration conditions during the storage. For example, sweet corn. If we store this food product at room temperature in 21 degrees, we will lose 50% of its initial sugar content in one day. But if we store this food product at 0 degrees, we will lose just 5%. So, if we can see, is a difference for about 45%. And it's a high value of the sugar content that we will lose if we don't control the storage condition with taking, in this case, low temperatures like 0 degrees. So controlling the storage condition helps to improve the quality or to save the quality of many food products. The second example is fresh asparagus. If we store this food product at 20 degrees, we will lose 50% of its vitamin C content. But if we store this product at 0 degrees, we will lose just 12% in a day. So this is, even in this case, it's a very high value of the vitamin C content that we'll lose if we do not control the storage condition. The last example that I'm gonna mention is broccoli. Well, the problem of broccoli is creating that yellowing appearance on its green color. But if we store it in refrigeration condition, this yellowing on it will be appeared after 3 or more days. But if we stored it in room temperature, this yellowing will appear very soon. So even in this case, we see that a refrigeration system for many food products or refrigeration conditions are very important because they save their quality and their nutrients. When we talk about refrigeration and freezing, we should know that the food products before or during these techniques have to pass through different stages. Well, when we talk about refrigeration or ordinary refrigeration of food, it involves just cooling, just one stage. But when we talk freezing of the foods, in this case it involves 3 stages, because there are low temperatures that the food product should achieve. So the first stage is cooling to the freezing point. In this case, it will remove the sensible heat. The second stage is freezing, and in this case, it will remove the latent heat of food. And the last stage is further cooling to the desired sub-freezing temperature. Well, in this case, it will remove the sensible heat of frozen food. Well, you should know that fruits and vegetables are live products, and thus they continue to give off the heat that adds to the refrigeration load. But if we want to extend the shelf life or the storage life of many fruits and vegetables, we will remove the field heat and cooling as soon as possible. The optimum storage temperature that we should use for a good refrigeration or freezing system is about 0.5 and 1 degrees above their freezing point. Freezing is one of the oldest methods for food preservation. It is used still early from the consumers to preserve their food product, and the most valuable fact that these techniques is used is because it allows to preserve the taste, the texture, and the nutritional value of many food products. The freezing process, like refrigeration, even in this case we have a combination of many beneficial effects of low temperatures in the food. As we have mentioned in earlier lessons together, low temperatures may affect on the microorganisms on the food, because microorganisms in low temperatures cannot grow, and of course they cannot produce or give metabolites that might destroy or spoil the food product. In low temperatures, many chemical reactions are reduced because the temperature, the high temperature is like a catalyst for many chemical reactions. But in this case, these low temperatures will freeze, will stop or reduce many of these chemical reactions. And the last one is cellular metabolic reactions are delayed. Well, in this case, the affection of low temperatures is well known and is happen to many food products. These are the most beneficial effects of the freezing process on the food, and makes us to choose these techniques or this process to create many food products and to store after this, to store these products with a high quality and high value of the high nutritional value. For freezing fruits and vegetables are used many methods of freezing. The most important freezing methods include air blast freezing, contact freezing, immersion freezing, cryogenic freezing, and the combination of the methods above. Let's see each of these methods. Well, air blast freezing. The easiest method of freezing is to place food product at low temperatures in well-kept storage room at sub-freezing temperature. In this case, the heat transfer is done by natural convection, which is a very slow process. Well, the resulting low freezing rate causes large ice crystals, and these crystals may damage the cells of the food product, so it will change or it will destroy the cells, many aspects of the quality of the product, the aroma. So these simple methods of freezing is usually avoided to use. The other methods of freezing is through the use of large fans in cooling rooms to increase the convection heat transfer coefficient and of course the freezing rate. These freezing methods are still being used for many food products, but nowadays these methods are being replaced by conveyor type freezers, as they allow automatization process and lower operating costs. For cooling uniformly sized fruits, vegetables, and other products is used a simple version of mechanized freezers. For smaller uniform products such as peas or carrots cut into small cubes, fluid bed freezers are used. When fruit products are suspended by a cold airflow, which is usually at minus 40 degrees, and the high level of movement air and large surface area results in high rates of heat transfer and rapid freezing of food products. Another air freezer method is when cold air acts on the food product vertically from both sides of the conveyor at high speed, causing high rates of heat transfer and, of course, very rapid freezing. Contact freezing. Well, in this method, food products are placed as a sandwich between two cold metal plates and cooled by cooler at low temperatures. The plates are cooled by circulating the coolant through their channels. Contact freezers are fast and effective, but their use is restricted to foods of no more than 8 centimeters thick with good thermal conductivity, such as meat fillets or fish fillets, etc. Immersion freezing. Well, in this method, food products are immersed in brine or in solvent which have a low freezing point, such as a nitrogen liquid. The low boiling points and safety of the use of cryogenic substances such as liquid nitrogen or carbon dioxide, etc., make them very suitable for cryogenic freezing of food items. A common type of nitrogen freezers involves a long tunnel with a moving belt in it. Food products will be freezed by nitrogen as they pass through the tunnel. Nitrogen provides extremely fast freezing due to a large temperature difference. Cryogenic cooling is another method, and this method is distinguished because of its high costs, and therefore its uses are limited. But to reduce this cost, especially to improve the quality of the product, this method is usually combined with other methods like air blast freezer. The food product is first frozen by immersing it in nitrogen bath in order to form a crust that helps the product to retain its moisture, its aroma, and then the product starts freezing with the method of air blast freezer. These are some of the methods of freezing that are used mostly in food industry. Thermal properties of the food. Well, refrigeration of the food is very important because it helps to preserve many food products and to extend the shelf life, as we said before. But also this process offers many challenges or considerable challenges to the engineers because the structure and the composition of foods and their thermal and physical properties vary considerably. In general, the properties of the food change with the time and temperature. This is the reason that we work or we control the temperature especially during the storage for helping this food product to stay fresh and with high quality. Storing the food product at low temperatures, as we said, will stop many or inhibit many chemical reactions that may destroy or may deteriorate food products. This is the reason that with the refrigeration we work especially with thermal properties of food. fruits and vegetables after harvesting. Part of them goes to storage in warehouses, and the conditions that are created in these warehouses should be controlled, especially by the temperature, for preserving the quality and the nutrients of the food products, in this case the fruits and vegetables. There is a problem with fruits and vegetables because they generate heat during the storage, because they consume oxygen and give off carbon dioxide, water vapor and other gases. And these generating of heat, it's a challenge for the engineers to preserve fruits and vegetables. Well, if we talk about thermal properties of foods, are mostly dominated by their water content. And in this group we can mention perishable foods, which are known for high water content. And is exactly these water parts of foods that turns to ice during the freezing. Well, in general, the freezing temperature is 0 degrees, because this is the freezing point of the water at atmospheric pressure. But 0 degrees is the freezing point of water, but it's for pure water. And it is known that foods, we cannot find pure water. This is the reason that freezing temperature for these products is different, and it will be changed to from product to product. In general, food products freeze over a range temperature. We cannot use just a single temperature for freezing them, because the composition of these food products is different. In general, the freezing temperature is between minus 0.3 and minus 2.8 degrees. But in the absence of the exact data, the freezing temperature can be assumed to be minus 2 degrees for meats and minus 1 degrees for vegetables and fruits.